Assalamualaikum warahmatullahi wabarakatuh. I'm Suri Fandani Ningsih from 6A class, English Education Department. In this location, I will explain about chapter number 7, Bivariate Analysis, exploring differences between scores on two variables. Bivariate analysis means the analysis of bivariate data. It is one of the simplest forms of statistical analysis, used to find out if there is a relationship between two sets of values. It usually involves the variables x and y. Bivariate analysis is the simultaneous analysis of two variables. It explores the concept of relationship between two variables, whether there exists an association and the strength of this association, or whether there are differences between two variables and the significance of this difference. There are three types of bivariate analysis. The first type, numerical and numerical. In this type, both the variables of bivariate data, independent and dependent, are having numerical values. The second type, categorical and categorical, when both the variables are categorical. The third type, numerical and categorical, when one variable is numerical and one is categorical. Exploring differences between scores on two variables. We will be looking at ways of determining whether the difference between the distribution of two variables are statistically significant. For example, when analyzing data, we may wish to know the answers to some of the following kinds of questions. Is the proportion of black to white workers the same among men as it is among women? Do women workers earn less than their male counterparts? So, in looking at difference between two variables, the variables which we use to form our comparison group usually has a small number of values or level, say between 2 and 6. We shall call this the comparison group variable to distinguish it from the other one which we shall refer to as the criterion variable. The comparison group variable is sometimes known as the independent variable, and the criterion variable as dependent one. There is a relatively large number of statistical tests to determine whether a difference between two or more groups is significant. In deciding which is the most appropriate statistical test to use to analyze your data, it is necessary to bear the following consideration in mind. The first, categorical data. If the data are of a categorical or nominal nature, where the values refer to the number or frequency of cases that fall within particular category, such as the number of black female workers, it is only possible to use what is referred to as a non-parametric test. For example, in trying to determine whether there's significantly more white than black female employees, it will be necessary to use a non-parametric test. The second, ordinal and interval ratio data. If the data are of a non-categorical nature, such as the rating of how skilled workers are or how much they earn, then it's necessary to decide whether it's more appropriate to use a parametric or non-parametric test. The third, means or variance. Most investigators who use parametric tests are primarily interested in checking for differences between means. Differences in variances are also normal carried, but only to determine the appropriate of using such a test to check for differences in the means. Variance is an expression showing the spread or dispersion of data around the mean and is the square of the standard deviation. If the variances are found to differ markedly, then it may be more appropriate to use a non-parametric test. However, differences in variances may be of interest in their own right, and so these tests have been listened separately. For example, it may be reasonable to suppose that the variability of job satisfaction of women will be greater than that of men, but that there will be no difference in their main scores. In this case, it will also be necessary to pay attention to differences between the variances to determine if this is so. The fourth, related or unrelated comparison groups. Which test you use also depends on whether the values that you want to compare come from different cases or from the same or similar one. For example, you are comparing different groups of people such as men and women or people who have been assigned to different experimental treatments. Then you are dealing with unrelated samples of subjects. It is worth noting that this kind of situation or design is also referred to in some of the following ways: independent or uncorrelated groups or samples, and between subjects design. If, on the other hand, you are comparing the way that the same people have responded on spread association or under different conditions, then you are dealing with related samples of observation. This is also true of groups of people who are or have been matched or paired on one or more important characteristics, such as, for example, husband and wives, which may also make them more similar in terms of the criterion variables under study. The last, two or more comparison groups. Different tests are generally used to compare two rather than three or more comparison groups. Okay, I think that's all my explanation about Chapter 7. Sorry if I had mistake. Thank you for watching and Assalamualaikum warahmatullahi wabarakatuh.